Alrighty, looks like. Okay, let's do this. Alright, find the length of the longest common prefix. Previously done it. Okay, medium. You're given two arrays with positive integers, array 1 and array 2. The prefix of a positive integer is an integer formed by one or more of its digits, starting from its leftmost digit. For example, 1, 2, 3 is a prefix of integer 1, 2, 3, 4, 5, while 2, 3, 4 is not. A common prefix of two integers a and b is an integer c, such that c is a prefix of both a and b. For example, 5, 6, 5, 5, 3, 5, 9, and 5, 6, 5, 5, 4 have common prefix of 5, 6, 5 and 5, 6, 5, 5, while 1, 2, 3 and that do not have common prefix. Can you find the length of the longest common prefix between all pairs of integers x, y, such that x belongs to array 1 and y belongs to array 2? So between 1 and 1,000 is 1. 10 and 1,000 is 10. 100 and 1,000 is 100. The longest common prefix of 100 is length of 3. Between all pairs. Okay, so you find the longest common prefix of both. So here is just 0. So you have to do something where you the common prefix of every possible pairing. Common prefix of every possible pairing. I assume you can't do this in n squared time. Let's see, it's 5 times 10 to the 4th, so it's 25 times 10 to the 8th. So that's 2.5 times 10 to the 9th would be 2.5 billion. 2.5. No, that's, yeah, 2.5 billion. Okay, these are values. These are number values. These are number values. Okay. What to do here? What to do? Number values, common prefix. Could convert them to string. Is there a way for me to leverage the factor into the numbers? So mainly I'm thinking that doing some sort of n squared algorithm, doing like a comparison of every possible combination, is too slow. But then how would I make it faster? How would I make it faster indeed? Remember when I took the course in DSA, there was something called the trie tree. TRIE, trie, where you create a structure that is like some sort of tree whose nodes are like characters in the string or digits in the number. So each node is one of those, and a path in the tree would be a string of characters or a string of digits that n terminate when the string or number itself ends. I could make a trie tree for I could make a trie tree for array 1. So the trie tree would look like 1 start node leads to 1 leads to an end node, which denotes that there's a possible 1, and then start node leads to 1, and then 1 also leads to 0, and 0 leads to end node, which means that there's a 10, and then start node leads to 1, leads to 0, and then 0 leads to n, and also so the trie tree would look something like 1 leads to end, or 1 leads to 0, which leads to end, and then 0 also leads to another 0, which leads to end. So it's like this is one branch, and then 1, and then this is another branch, and then 1, 0, and then this is another branch. And then once you have the trie tree for array 1, then for every value in array 2, you kind of traverse the trie tree to see how far it goes. Wonder if that's too slow still. You have to do 8 traversals because there's 8 digits for every number. This is almost like a constant cost. I think this in theory is O of n, which obviously is pretty fast. I guess I might as well try it. Try it. I'm honestly unsure about the syntax though. The syntax, the bane of my Python existence. Let's go ahead and just ask Google there. Python try class node example. Class try node. Okay, I think this is good. I don't need much more than this. I generally don't think I saw this one before. The boolean is end. Maybe I can say is n is false. Okay. Was the children a list or was this set? Or I guess this is a dictionary, huh? Yeah, I guess a dictionary would work here. Okay. I'll just say this is from Google search of try node example class. I'll just make sure that I don't give the false impression that I just made that up on my own. Okay. So I'm going to go construct the trie tree for all numbers in array 1. Okay. Guess I'm actually converting to strings, to be honest. So for every number in array 1, actually I probably need to create a trie. Do I need to create trie node? Yeah, I think I need to create trie node here. So let's see, I'll call it tree, which is going to be a trie node of an empty. Yeah, I think that's right. Yeah, okay. And then this is for every number. I'm going to convert that to numbers to a string. I'll just, string number is going to be string of the number. And then I'm going to iterate over the characters of the string. So for every digit in snum, how would this work? I guess I need to go current is equal to the current tree. And I'll need to iterate over the nodes in this tree. So current of this digit, I guess maybe if this digit is in the children of the current, then that's fine. I guess if it's not, then that's not fine. If the digit is not in the children, then current dot children for this digit is going to create a new mapping to a new trinode. And then current is going to go to that trinode. Current is now equal to current of the children for this digit. So it's gonna move to that node. Otherwise it moves that node. Actually, otherwise it does this, right? If it's not there, then it creates a new node. If it's already there, then it moves that node. Yeah. And then I guess at the last node, it just does something that is current dot end is equal to true. So that means that yeah, so we go 1. Actually, so there's some kind of start node here, and then the start node actually leads to like the children of that start node has, or the children dictionary of that node has 1 is added 1, creates a trinode, and then that trinode has an empty list of, or an empty mapping of children, and now it's set to true for being an end state, an end node. Okay, I think that's fine. Okay, and then answer is equal to 0, and then for every number in array 2, this is going to kind of, what's the term here? It's not constructing the trinode. Walk down tree for every, actually I actually don't know if I need to have a current.end, because if it doesn't have anything, then it just ends it ending itself, right? If there's no children. Okay, whatever. I'll figure that out in a bit. Walk down tree for every number in array 2, and then when it stops for every number in array 2. So I'll go snum is equal to string of this number, and then current is equal to tree. And then maybe I shouldn't call this tree. Maybe I should call this the start node. I'll just start. And then it would be something like for every digit in, actually maybe I need to track Let's track the path length. Current length is going to be 0 for every digit in snum. Or maybe I should do, oh, that's fine. If digit is in current.children, then current.children of digit, no. Then it walks down that path. So current equals current.children of that digit. Else is going to stop. It's going to break here. And this thing means I should do something that is path plus equals 1. Otherwise it breaks because there's no actual connecting prefix, or yeah, the prefix doesn't go further. Common prefix doesn't go further. And then answer equals max of answer, and however long this path is. I think that might be it. I guess I didn't need the current.n equals true or false. Let's see if it works in the test cases. It does. Okay, I'm fairly confident I don't need the current.n. Dictionary where keys or characters and values are tri-node objects. Yes, I mean, I guess that is fine. Guess I'd probably prefer it to be something like this. Maybe I should use an if statement here. Else break. What I want. Every digit. Maybe I prefer something that looks like this. If digit not in current.children break. And then otherwise do this. I think I like this slightly better in terms of overall look. Yeah. Alright, let's see what stupid test cases I failed at. I'm sure there's probably some. Okay. It's okay. It's okay. So it is an O of n solution, I'm pretty sure. Was there a faster way of doing all this? Basically it's a dictionary of dictionaries. Each node has a dictionary. Go. Could I have done this without creating a tri-node class, or using something of that sort in that data structure? I'm not generally a fan of actually creating my own or adding additional data structures. I guess this is a very simple data structure, right? But can I do with like just lists or something? Prefix component is formed by one or more signs. 1, 2, 3, 1, 2, 3, 4. Common prefix is 2 integers C. And find the length of the longest common prefix for all pairs of x, y. All pairs of x, y. 5 times 10 to the 4th. I mean, how many prefixes would there be? So in theory I could do something where I already used a bunch of memory. I was thinking maybe like creating every prefix into a hash, into a mapping or a set. Maybe have something where every prefix into a set. That would you know what, I think I wonder if sorting it would help at all. Sorting would help at all. Because it's only possible to have combinations. I mean, sorting. Sorting definitely wouldn't help in the construction of the tree. Would sorting help at all in the... Okay, I think what I can do is if the length of the current number is smaller or equal to the current answer, then skip it, right? You don't have to traverse down that path. If skip number if not possible to be better than current answer. So if the length of snum is less than or equal to the answer currently, then we continue. I'm assuming this would probably be some sort of improvement. Okay, 60%. Trying to figure out whether or not sorting would help at all. No, this is really bad in terms of these values being the same. Okay, I think what I can do is I can do for everything in the set of the number. So creating to a set means that it doesn't actually handle duplicates, or ignores duplicates, right? Because apparently they really like to have duplicates in this list. Okay, that's another improvement. What else? I mean, would sorting help at all? In what world is sorting going to help? In theory, you want to do the longer ones first, because the longer ones will allow you to have the longest prefixes, and then anything that is too short afterwards you just ignore. So I think if you wanted to do the longest ones, then it doesn't make sense to so I think I need to create the list and then sort the list by the length of the value, length of the string. Oh, that's so disgusting. Honestly, I think that might actually be okay. Let's just quickly verify how disgusting it is. Sorted list is going to be sorted. I think that's the function. It's going to return the sorted list. Actually, S list is going to be list of the set of array 2, and then slist.sort by key equal to lambda x, where I'm going to use negative of the length of the string version of this value in the thing. So x is just iterating over every value or number in the sorted array, converting that to a string, making that string into a number, the length of the string. And because it normally sorts it in ascending order, that would make the front side be smaller, so therefore I make it negative so that the longer numbers are bigger negatives, so that becomes the front. Oh, I forgot to actually iterate over S list. Okay. I don't think that was an improvement. That wasn't strictly worse. It's very similar. Skip if it's not possible. I guess if it's not possible at this point, I can just break, right? Because everything after this in the list is going to be that length or shorter. Okay, that might be a slight improvement over the previous one, unless the previous one is just kind of random. It's kind of random. Alright, I think I'm done. I think I'm done with these small hacks. I don't even know if they're called optimizations. Alright, our optimizations would be too generous a description. Alright, summary. Use a tri-node kind of tree structure to convert the nums, or convert array 1 to a tree where with nodes that are digits whose children are following are possible kind of succeeding following digits, and where a path from start node to end or to leaf node in tree represents a number in the array. Yeah, you just kind of might want to look up that stuff if unfamiliar. And then once the tree is constructed, iterate over the values in the second array for each value. See how far or how long the path is until it reaches a digit that does not have a path, and then update answer if path length is longer, if the current path length is longer. Current path length being kind of the common prefix. Optimizations, I'll put in quotes. Converted arrays to sets to avoid handling duplicates. Also kind of sorted the second array and broke early if trying numbers whose length is less than or equal to kind of answer length, i.e. it's not possible improvement, not possible to improve answer. I think that's pretty much it. Yeah, so this is the trinode class definition. And then you have your start node, which is your default kind of starting point. Like doesn't actually have a character, it just has children, where the children represent basically the first. The children is a mapping or dictionary where the keys are going to be all the possible kind of first digits in the numbers, and then so then you construct for every number kind of its path in the tree. If there is no for every digit, if the digit doesn't exist in children at this node, then it adds a node, and then it moves from that node to the following node, and then kind of builds the path onwards from there. After you have your tree constructed, you're going to go, this is just the optimization stuff, you can ignore that. It goes every number in the second list, and then again it does the traversal down the tree until it reaches a node that doesn't find or digit doesn't find in the children list, children mapping. And if it does, then it just traverses further and increases the path length, and then it updates. Alrighty. Alright, I guess that's it. Cool beans, cool beans.